Greetings, everyone. Welcome to the third stream. So the third free lesson today is all about the ionic product of water. Okay, if you can hear me, can you put a plus in the chat, please? Okay, I was a little bit eager to get started, so I started a little bit before 5. So, thank you very much, Divya. 3 pluses. Superb. Anyone else? If you can hear me, big fat plus in the chat. So today what we're going to do is we're going to look at the ionic product of water. So we're going to build upon what we've done in the previous 2 lessons. So first lesson was an introduction to strong acids. Second lesson, we looked at some calculations and introduced the ionic product of water and using those to calculate the pH of pure water at different temperatures. And now we're going to use the ionic product of water to calculate the pH of strong bases. How long are these lives? Presumably we mean live streams. How long are they going on for? So today's lesson is probably going to be about 50 minutes to an hour. Maybe go over a little bit. I'm not really sure. Yeah, so we've got 3 more lessons after this, and that should be a really good introduction or a fairly good chapter to close on. So we should have finished pH from strong acids to weak acids to buffer solutions, should have everything apart from pH curves done. So thanks for that question, Tommy, makes it look easy. Okay, anyone else put a big plus in the chat and then we'll get going. Big plus in the chat if you can hear me. If not, we're going to get going. When will we finish the content in Jan? So what do you mean by that, Divya? Okay. So I've already asked you to put a big plus in the chat if you can hear me, and many of you have, so thank you very much for that. I'm just going to go over what today's goal is as well. So today's lesson is to help us obviously understand acids and bases a bit better. But really the goal of today's lesson is to go through the ionic product of water again and to actually use and to utilize the ionic product of water so that we can go through strong base calculations. So it's just a question in the chat from Divya, like the whole course for year 13 because we're going to start papers soon for maths. Hello, Benedict. Hello, Giovanna. So yeah, this is just a series of free streams. We're only going to do 6 of these, so this should be done by January, and then we'll talk about the course that I'm offering, which starts in Jan, and we're going to go over everything in year 13 in that course, but more information on that later. Dennis, greetings. Right. And talking about that, Divya, one last thing. Right at the end, we'll talk about my A-level exam prep course, so you can decide if that course is going to be good for you based on the stuff that we're putting on social media and these free streams as well. Tommy makes it look easy. Well, you know, what I say is train hard, fight easy. You know, if you do this now in year 12, you'll be ahead of the game. All right, let's just quickly get to know each other as well. So in the chat, can you just write down which city you're from? Then I'll tell you a little bit about myself. Any Londoners here? Any people from the Midlands? Tommy makes it look easy. Essex, fantastic. Lakshmi, London, superb. Narmeen, Bristol, excellent. Lovely bridges in Bristol. Fawaz, will your course cover all Chem A-level content for year 13 before the exams? I think that's a bit ambitious. Divya, the Midlands. Dennis Peter, Kenya, international, superb, love it. Fawaz, Aylesbury, excellent. Any more international people? Okay, so thanks for telling me a little bit about yourselves. I'm going to briefly introduce who I am if you don't know already. Sajay, Birmingham, superb. So my name's Vinda Batchu and I'm head of chemistry here at MyEdspace. I'm a fully qualified teacher with over 8 years of teaching experience. I've always taught in state schools in London. I'm a UCL grad with a first class honours degree in pure chemistry. Yes, there are some people who do pure chemistry as a degree. Yeah, I'm thinking what is wrong with them as well. And then point number 4, which is a really impressive statistic actually. Last year in my school, 48% of my cohort got an A star or an A, and that's absolute phenomenal achievement on their part. There's a point missing, so I'm just going to add point number 5 manually. I've also got a doctorate in chemistry, so inorganic chemistry and materials chemistry. So after my bachelor's degree, I stayed on to do a doctorate in chemistry. So the point of this bit is that I really do like chemistry. When people say they're passionate, everyone says they're passionate. I really am passionate about chemistry. I'm one of those people. So, some rules to follow. Okay, could I ask you what some rules to follow are in the chat? Fire away. What are some rules that we should all adhere to in this free stream so we can make it enjoyable for everyone? Don't be shy. Fire away. Don't answer all at once. But clearly, this was a fairly big sentence to write. There is no such thing as a bad question. Obviously, there's no such thing as a bad question. Don't be shy, ask away. The likelihood is that somebody else is thinking that question too. And what you've done is you've just opened the floor and made it acceptable to ask a question. So well done if you ask questions, okay? You'll get more out of this. Also, there are moderators in the chat room to help me answer your questions as well. So just be aware of that as well, please. Right. Like we say every week, before we can get going, you need a piece of paper. Ideally, you can use an iPad or some sort of tablet writing device, entirely up to you. You need a pen or pencil. This is a mechanical pencil. The choice is entirely yours. And you also need a calculator. Neil does maths, laughs at my crusty calculator, but I've had it for a long time, so I'm sticking with it, okay? Right. Can you put a plus in the chat if you've got all of that ready and you're raring to go? Pluses, please, pluses. Go, go, go. Excellent. Divya, super. No, I mean, excellent. Right. Going to give you around 30 seconds to get all the stuff that you need to make the most out of this lesson for us. Excellent. When are the biology? This is a chemistry lesson. Toby makes it look easy. I don't know. One of the mods can tell you when the biology lessons are. In fact, Divya's done it for you. It's on Wednesday. Right. Let's go. We're going to start with a bit of a recap. Okay. So, ionic product of water. Answers in the chat, please. Can somebody tell me what the ionic product of water is at 25 degrees C? So I'd like the equation for the ionic product of water and a numerical value for the ionic product of water at 25 degrees C. Answers in the chat. Go, go, go. Okay. Let's think back. So the ionic product of water is Kw for was 1 times 10 to the power of 14. Okay, we'll think about that in a sec. So Kw is equal to the concentration of H plus ions multiplied, hence product, by the concentration of hydroxide ions. Okay, now, for was good save. Okay, Kw is equal to 1 times 10 to the minus 14 moles squared dm to the minus 6 at 25 degrees C. Why do I have to quote a temperature? Why don't I just say the number and not quote a temperature? Not a trick question. We covered this last week. Because K is a constant for a specific temperature. So what we're really saying here is that the value of K is dependent on the temperature at which the reaction occurs. Okay, for this next bit, it's going to be really useful to write some stuff down, okay? We should be writing stuff down with me. So when I write, you write. We're going to use a few tricks, okay? We're going to use some variations of this equation. So this equation is really useful. So let's put a box around that. Now, what we can do to this equation is, I'm going to stick in a numerical. Doing well, Johnny Guest. Right. How are you? So what I'm going to do is I'm going to stick in a numerical value for Kw in. Okay. And what we're going to do is we're going to take negative logs of both sides, okay? So, if we take the negative log of 1 times 10 to the minus 14, on your calculators, what do you get? Of that number, what do we get? So you should find out if you take the negative log of 1 times 10 to the minus 14, you get 14. Now, if you take the negative log of the hydrogen ion concentration, what quantity do you get? Well, the negative log of the hydrogen ion concentration is equal to the pH, right? And you can look at your log rules here. I'm not going to convert this into a maths lesson, but if you take the negative log of the hydroxide ion concentration, any ideas what you're going to get? You're not going to get pH, but you are going to get P something. Any ideas? It's not pKa. Yeah, it's POH. Absolutely. Absolutely. So, for example, the negative log of Ka is equal to pKa. The negative log of the hydrogen ion concentration is equal to pH. The negative log of the hydroxide ion concentration is equal to POH. Okay, the negative log of Dave, if you want, is PDave. Right, so this is just the P exponent, okay? I've just gone through all the variations plus one anomalous one of what this P exponent means, okay? So we can rewrite this as 14 is equal to pH plus POH. Now this is another useful form of effectively the equation at the top. We're going to go through using both today and you can decide which one you prefer. But before we move on, plus in the chat if you're happy with what I've just done. All we did is we had the Kw expression, we took negative logs of both sides. Because we had a product, we end up with pH plus POH. Okay, Fawaz, Amarth, Namin, thank you very much. Johnny, superb. Giovanna, excellent. Okay, greetings. Excellent. Will lessons always be like this? Give me some more. In the words of Busta Rhymes. Okay. So, sorry, maybe you're a bit... Busta Rhymes is probably just an old person thing. Right, some rules. What are some rules? Let's just quickly recap what some rules are. So, KW, rule number 1. KW, banger, absolutely. I'm not going to do a rendition of it though, don't worry. Okay. Point number 2. 14 is equal to pH plus POH. Okay, so just be aware of those. Also, just be mindful of, don't forget this because it was right at the beginning, but pH is equal to the negative log of the hydrogen ion concentration, and obvs, POH is equal to the negative log of the hydroxide ion concentration. Right. Everyone happy? If we are happy, I don't mean in life, I mean it's a sort of value judgment, but let's move on. If you're happy with these rules, that is. So, we're going to do some more complicated stuff today using the ionic product of water. So, Sajay, if we register onto the course you teach on YouTube, can we not speak with you? Yeah, of course you can. Absolutely. But some of the mods will reach out to you for some extra information on courses. Yep, I'll always try and interact with you in the chat as well. So, question on the screen is, use the ionic product of water to determine the pH of a strong base. Well, before we do that, we have to determine what a strong base is. So, hands up. What is a strong base? Obviously, you can't do hands up, but in the chat, can you write down what a strong base is? Any takers for that one? Well, we know what a strong acid is. A strong acid fully dissociates in water. Absolutely, Johnny, smashing it. So, a strong base fully dissociate in water. Okay, so there's no partial ionization here, okay? And just as a reminder, what is the Bronsted-Lowry definition of a base? A base is defined as a proton acceptor, okay? So, remember the Arrhenius definition of a base is a species which dissociates into hydroxide ions, and the Bronsted-Lowry definition is a proton acceptor. What are some typical strong bases that you should be aware of from your chemistry journey so far? I'm talking like include key stage 3, include key stage 4 up to now. Yeah, sodium hydroxide, absolutely. So, sodium hydroxide is, yeah, Emma's actually got it. Johnny's got it. Fawaz has got it. So, sodium hydroxide is a solid, comes in pellet form. You dunk that into water, that splits up into Na plus aqueous and OH minus aqueous, okay? Just like we did for strong acids, it's really important in the chemistry scheme of things to write out your dissociations, okay? Now, Amma said group 1 and 2 metals with hydroxide. Yeah, so if you've got a group 2 metal with a hydroxide, let's say magnesium hydroxide, what is the formula of magnesium hydroxide going to be? Is it going to be MgOH? So the definition is the same for strong acids and bases? Yeah, absolutely. Correct. It's just the definition of a base is different from the acid, but the strong bit means fully dissociates in water. Yep, absolutely, guys. Good stuff. It's going to be Mg bracket and a 2 outside the bracket, okay? Because the magnesium has a 2+ charge and hydroxide ions have a 1- charge. So if we dunk this into water, for example, we're going to generate 1 magnesium 2+ ion, AQ, and we're going to have 2 hydroxide ions per 1 mole of magnesium hydroxide, okay? So these are just some tips and tricks to look out for. The exam board, yeah, let's call it dibasic. Why not? Why not? These are some sort of tricks the exam board wants you to fall into, so you say, no, I am aware of what you're trying to do, and I'm not going to fall into those traps. Okay, well, let's have a look at a question. Calculate the pH of a strong base. Okay, so you've got to calculate the pH of a 0.1 mole per dm cubed solution of sodium hydroxide, okay? So, what are we going to do first? Before we do any calculation, step number 1. Where are we going? Before we do any maths, we are going to write out the base dissociation, okay? So, we've written it out loads. Ooh, are we going to multiply by 2 here? Are we? We'll come back to that, Johnny. We're actually going to do some of those in a second. So, this is going to split up into Na plus and OH minus. And the whole point of getting you to write out the dissociation is not because I like saying it's really important to do this. It's so that we know what the molar ratio is between the associated base before it goes into water and dissociates, okay? So it's there to help us. Okay, step number 2. Where do we go next? So we can work out the constant. I'll do this 2 ways, okay? So we know, yeah, I need to work out the hydroxide ion concentration. Well, I can annotate this dissociation, okay? So I know that I've got 0.1 molar NaOH, okay? So have a look at the dissociation. So we're also going to have 0.10 moles per decimeter cubed of the hydroxide ions. So we know the concentration of hydroxide ions. So the concentration of hydroxide ions is equal to 0.10 moles per decimeter cubed. Okay, that's useful. It's only useful if you remember the Kw equation, Johnny. Correct. So Kw is equal to H plus times concentration of hydroxide ions. Now, let's just have a think. They haven't given us a temperature here, but what can an assumption be? That this was what? Room temp, okay? So the fact that this is room temp, we know Kw and we know the hydroxide ion concentration. So what can we do? We can rearrange. What can we rearrange this for? Bobstigalik, correct. So let's rearrange this. Kw over the hydroxide ion concentration, if you divide through by hydroxide, is equal to the hydrogen ion concentration. So, no, absolutely not. A decimeter cubed is a liter, so yeah, same thing. Okay. Right. Now, I always like rearranging before I put numbers in. So let's put some numbers in now. Let's sub in. Divided by 0.1, not 0.01. So this is going to be equal to 1 times 10 to the minus 13. So that's what the hydrogen ion concentration is equal to. So if the hydrogen ion concentration is equal to that, I know that the pH is the negative log of the hydrogen ion concentration. So the pH of the negative log of 1 times 10 to the minus 13 is going to be 13. Super duper. Happy days. Okay. That's one way of doing it. Would you like me to show you the second example using the 14 equation here or on the next example? Let me know in the chat. Should we do it on the next one? Let's do it on the next one. Unless you say otherwise. Okay. Let's go. So, question A, calculate the pH of this solution. All right. You're given Kw in the formula book. Are you given Kw in the formula? I don't think you are, you know. No, I don't think you are. I'll double check that. But I can't remember the formula book from heart, but I don't think you are given Kw. All right, you are? Okay, Fawad says, yep, okay. They will state if you are not going to use 1 times 10 to the minus 14. So if it's at a different temperature, they'll tell you what Kw is at that temperature. Okay, I think OCR. Okay, cool. I'll have a look for AQA. I'll double check for AQA and Excel. Right, step number 1. What do we do? Let's say it together. Yeah, OCR give way more stuff. They even give you like, yeah, but whatever. Right. We write out the dissociation. Why are we writing out the dissociation? To see. Yeah, equation. Good. Okay, we're doing that to see that it's a one-to-one relationship between the base and the hydroxide ions. Okay, super. Where do we go next? Well, what could we do here? So I know that the concentration of hydroxide ions, let's have a look at that. So the concentration of, what example do you teach? So mostly taught AQA and Edexcel and a little bit of OCRA as well. But in my opinion, chemistry is chemistry. It doesn't really adhere to an exam board as well. So if we know that the concentration of KOH is 0.15, therefore the concentration of hydroxide ions is also going to be 0.15 moles per decimeter cubed. Okay, what could we do next? If I know the concentration of hydroxide ions, what could I work out? From minus the log of the concentration of hydroxide ions. That is equal to what? POH. Am I superb? Okay, so if that's POH, excellent for us, Johnny. Super. Right, so let's do that. So let's actually put that value in. Negative log of 0.15. That's going to give me POH. So hold me accountable. Check to see if I'm doing this correct. I could be rushing and making a mistake, okay? So I'm just going to say 8239. So POH is equal to that. Everyone getting the same thing? If so, let's continue. All right. Where do we go next? Well, next I'm going to write down 14 is equal to pH plus POH. Okay. Well, I know POH. I just worked it out. I know 14 is given to me. I know that. So what do? I take 0.8239 away from both sides to give me the pH. So the pH is equal to 14 take away 0.8239. So pH is equal to 13.18. Happy days. Okay, can you just tell me in the chat which method it's a standard value for? It's a standard value for 25 degrees C, okay? It's temperature dependent. All right, can you just let me know which method you prefer? Method number 1 or method number 2? This is method number 2, so just put a 1 or a 2 in the chat so I know which one you're referring to. Tommy makes it look easy. This was way easier. Some people like method 1. Excellent. Method 2, method 1. Now I'm going to say you've got to make a judgment call here. You've got to go with one that you can get the answer for. Does temperature make a difference to the value of kW? Absolutely. Check last week's lesson where we talked about how temperature can affect the value of kW, okay? So yeah, it does. Okay. Oh yeah, we're going to do one more example here. So let's do this. We're going to do quite a few examples, okay? Because practice makes permanent. So what do we do first of all? We're going to write down the dissociation. So let's do it. Like a robot, I'm going to do that. So where do we go next? I can work out the concentration of hydroxide ions, and the concentration of hydroxide ions is 0.05 moles per decimeter cubed. How do I know that? Because it's a one-to-one relationship between the hydroxide ions and the sodium hydroxide. Okay, where should we go next? Shall we use method 2 again? So POH. It's really good to annotate what you're doing in the calculation so the examiners can see the steps that you've used for the calculation as well. So I'm going to do the negative log of 0.05 and write in the chat as well. What are we getting? I'm hideously tired, so I could be making a mistake. So just make sure that I'm doing this correct and say, oi, you've got that wrong. So question number 4, or part number 4, what do we do next? So I've got POH, and then I'm going to write down 14 is equal to pH plus POH. So then part number 5, I'm going to say that the pH is equal to 14, take away 1.30. Is everyone getting 12.7? Maybe to quote to 2 decimal places, okay? So make sure you put 70 there as well. Fawaz, excellent. Divya, super. Anyone else? Si. Grazie. Johnny, yeah. Super. All right. It's a good technique. Can you just put a plus in the chat if you've seen that at school before, if you've done this topic? If you've seen method 2 before. Do sig figs matter here? I wouldn't say sig figs do, just 2 decimal places is usually the convention that you'd use here. Okay, so you've seen this. Great. Excellent. Okay. Can't lie, I don't know this topic existed. Okay, you haven't seen method 2 before. Okay, good. Well, that's every day's a school day, I say, so it's hopefully we've learned something new, okay? Now, this one is what we seeing? All right, Fawaz is in diabasic question. Let's go. Yeah, it's the level of complexity is fairly straightforward and how they're going to try and trip you up. But yeah, absolutely. It's a diabasic base, right? So, Asya, yep, absolutely. Where do we start? What do we do? We start with the dissociation. Yes, am I correct? So, barium 2 plus 2OH minus, okay? Now, at this point, I'm even going to annotate it here, okay? So we know we've got 0.20 moles per decimeter cubed of. I'm just going to use big M for molarity because I'm getting tired of writing out moles per decimeter cubed. Okay, so what is the concentration of the hydroxide ion going to be? We'll have a look at the ratio. It's a 1:2 ratio, so what do we need to do to this number? Times it by 2. Speaking of Busta Rhymes, that was a bit of DMX for you. DMX, fantastic. Rest in peace. Okay, so that's 0.40 moles per decimeter cubed. Okay, where do we go next? What do we do? Oh, come on, we're not stumped already. What's our next heading going to be? Yeah, I would... Does the order matter? I would always do it this way. Working either moles or moles per decimeter cubed first and then go through and do the log stuff, okay? So yeah, absolutely find pOH. So I'm just going to write down, let's do pOH then. pOH. Okay, so that's going to be the negative log of, make sure you pick the correct one, 0.4. Okay, negative log of 0.40. Okay, check. Am I doing this correctly? I get 0.40. Okay, so that's pOH. Part 3. pH plus pOH is equal to 14. So pH is equal to 14, take away pOH. So the pH is going to be equal to 14, take away 0.40. So the pH is equal to, what is the pH equal to here then? What do we get? 13.6? 13.60? Yeah, happy days. Good stuff. Sammy, Divya, keep up the good work. And how are we finding this so far? Johnny, superb. Put a plus in the chat if you're like, yeah, this is all right. And now I know some traps that they're trying to make me fall into, but I can say, no, I'm not going to fall into those. Super. Amma, Divya, excellent. Thank you, Sammy. Super, Johnny, super duper. Right. Let's get cracking then. Giovanna, excellent. I hope it's helpful. Okay. Let's have a look at the next one for us. Thank you very much. Thanks for the plus. All right. They have juggled the question around this time. How many marks is a question like this from Tommy makes it look easy? Probably 3 marker. If they're being harsh, 2, but normally 3. Okay. Calculate the concentration of the base from the pH. Okay. How are we going to start this? I mean, there's many ways to do this problem. Any suggestions? What can we do? Okay, all right, let's have a look. So we're saying, all right, before we even start, so let's do NaOH goes to Na plus OH minus. So we know it's 1-to-1, okay? So that's all good. All right, let's use 14 is equal to pH plus pOH. Well, what do we know straight from the question? What's given to us? Johnny's on it. Yeah, what's given to us? We're given the pH, right? So we know that, and we know that. So 14 take away the pH equals pOH. Is everyone with me so far? So let's do that. So if we do 14, take away 14.30, that's going to give me the pOH. So pOH is equal to minus 0.3. Okay, good. So that's what the pOH is. So how do we actually work out the hydroxide ion concentration? I'll do this just as a reminder. So the negative log of the hydroxide ion concentration is equal to pOH. So what could we do? Yeah, 10 to the power of, absolutely. So step number 5, 10 to the power of minus pOH gives me the hydroxide ion concentration. So what we're going to do, 10 to the power of minus 0.3. Okay, so let's do that. Shift log. What do we get as a hydroxide ion concentration? I've got a value. So we should get 1.995. I'll put that in for now. So the hydroxide ion concentration is equal to 1.995 moles per dm cubed. Okay, so we've worked out this quantity, but it's asking us to calculate the concentration of sodium hydroxide. Because it's 1-to-1, the answer is going to be exactly the same. But that is pretty concentrated stuff, okay? I'm not joking. I read earlier. So well done, everyone. Johnny, Fawaz, Divya, super. Everyone who said the correct thing, well done. Okay, I read an article earlier about a bartender giving some caustic soda with a beverage that people were drinking, which resulted in going to hospital and probably ingesting pH of 13, close to 14. So There you go. Real life, contextualizing chemistry. It's a chemistry-centered course. Right, well done, everyone. Let's move on. Okay. How do we do this? Let's do this in the same way then. This time you got barium hydroxide. Yeah, delicious. Yeah, absolutely. Not recommended with beverages, I'm going to say. But you know that now because you've attended this course. So, barium hydroxide with a pH of 12.50. Okay, let's do this together. So, collectively, let's write in the chat. Let's say how we're going to start. Start with... A good question from Johnny. How does a negative pH work? Well, in exactly the same way. So pH can be negative, it can be 0. If it's negative, it's all a problem really about solubility and can you actually dissolve it in the water. And if you can have negative pHs. Nothing magical, just adheres to the same formula. So this is a dibasic, okay? So it's a group 2. Dunk that into water, we're going to get barium 2 plus 2OH minus. Okay, right, I'm just writing that for clarity. Yeah, it means it's really concentrated in terms of hydroxide ions, I guess, or H plus ions. So if it's pH 13, it's very low in concentration of hydrogen ions, but really high in concentration of hydroxide ions. That makes sense. Okay, so let's start with our 14 equation. I mean, whatever works for you, I'm going to say. Okay, but we know 14, that's given to us, and the pH is also given to us at 12.5. So 14 take away 12.50 is equal to pOH. So everyone okay with this so far? 14 take away 12.50. Okay, what do we get as pOH then if we do that? Okay. Divya, just bear with. We're getting to that bit in a second, okay? I'll show you why I'm doing this approach. So pOH should be 1.5. Okay. Then, where do we go next? So I'm going to say that 10 to the power of minus pOH is equal to the hydroxide ion concentration. Okay, so 10 to the power of minus 1.5 is equal to 0.0316. Hands off, we're getting that. Okay, so part 4. Johnny guessed, excellent. Sammy, excellent, good. All right, so we've got the hydroxide ion concentration because I just worked it out. Just going to double check that I'm doing this correctly. Yeah, that is correct so far. Okay, step number 4, where do we go? So I've just worked out the hydroxide ion concentration. How am I going to get the concentration of the barium hydroxide? What do I need to do to this number? Is it multiplied by 2? So we've got this, okay? So we know this is 0.0316 or whatever it is. But have a look. The ratio between this and the barium hydroxide is 2 to 1. So we're not going to multiply this time. We're going to divide it by 2, okay? Sammy, correct. It is divide. So we're going to do 0.0316 over 2 to get our 0.0158 moles per decimeter cubed. Yeah, absolutely. Super. Good. And there you go. That's the concentration of the base before it dissociated, okay? So just remember, pOH is a measure of the hydroxide ion concentration. If it asks about the base, then you've got to look at the dissociation equation to figure out what it's actually asking you to do, okay? Same with strong acids as well. Okay, so put a plus in the chat if that was a little bit more tricky than what we've seen so far. Okay, it was a little bit more tricky, but not much more tricky. We can overcome that. Okay, plus in the chat if you found that a little bit more tricky. If not, I'll take your silences. Absolutely nailing this. Okay. Right, C. Thank you very much, Sammy. Much clearer when you write the equation out. Excellent, Johnny. Thank you very much. Okay. KOH with a pH of 13.7. I'm going to write the equation OBS because we write the equation out in this class because it's chemistry, not maths. Okay, step number 2, where do we go? Okay, straight away I've seen it's 1-to-1, so let's write down 14 is equal to pH plus POH. So I know the pH because it's 13.7, so I know 14, it's given to me, and I know the pH. So 14 take away 13.7 is equal to POH. Okay, so 14 take away 13.7 is equal to a POH of 0.3. Cool, blimey. Okay, cool. 10 to the power of minus POH gives me the hydroxide ion concentration. So the hydroxide ion concentration is equal to 10 to the power of minus 0.3. So 0.501? 0.501? Yep, 0.501. Absolutely. Put a plus in the chat if you got that. Okay, step number 4. That's a hydroxide ion concentration. Well, it's 1-to-1. So the KOH concentration is going to be exactly the same, 1-to-1. Therefore, it's going to be 0.501 mol per dm cubed. Happy days. Excellent. Well done, Amin, Johnny, Samia, Divya. Excellent. Fwaz, let me know if you want me to go over it again, Giovanna. Excellent. All right, cool. Let's ramp it up a little bit. Let's take it up a notch. All right. We're going to do something a little bit more tricky. Okay. Now, here we've got a strong acid-base mixture, okay? So this is, I prefer using the value for KW, even though that looks easier. Yeah, okay, let's do some KW ones, okay? You've got to go with what works for you. I normally use a KW one for, I'll show you that method. I've shown you both, and I'll try and use the KW method again if we have to do it in one of these questions, okay? Righty-ho. So, calculate the pH of the solution formed when you got sulfuric acid reacting with NaOH. Okay, now, a few notes on this question. Is this a buffer solution? This is not a buffer solution, okay? This is a neutralization reaction. So, let's write down neutralization reaction. Now, in its ionic form, what is a neutralization reaction? What ions are literally reacting? Well, the ion that's coming from an acid is H+, right? We need a proton acceptor here, and we usually call that proton acceptor OH-. Absolutely, Johnny. So, if you don't know this, get this down, please. So, H++ plus OH- forms the drink H2O in its liquid state, okay? It's really important. So let's think about how to attack this question. What I would do, because I think it's a better way, yeah, we need to find the number of moles of, step number 1, find the moles of H+. We're also then going to do, find the number of moles of, any ideas? So we're finding the moles of this, we're also going to find the moles of OH- ions. Okay, yeah, absolutely, Divya. Yeah, absolutely. Good work, guys. So, first things first. Is anything looking a bit suspicious? I mean, are they trying to trip us up anywhere? Do we have any diprotic or dibasic things going on? Well, straight away looking at this, yeah. Absolutely. Not dibasic. We've got a diprotic acid because we've got H2SO4 for us. Sammy, super. So let me show you how I would actually do the question. Step number 1, I'm going to write out my acid dissociation, okay? Why am I doing that? Well, if only H+ is reacting, let's write down that dissociation. Okay, so sulfuric acid is being split up into 2H+ and some sulfate. NaOH, monobasic, so Na+ and OH minus. Okay, so step number 3, I'm actually going to work out the amount of H2SO4. Just remember that amount means something technical in chemistry. It means a number of moles. So every time I say amount, it means mole. So how am I going to do that? I've got the volume and the concentration. Problem is that's 50 centimeters cubed. I need to convert to decimeters cubed, as Sammy said. Multiply it by 0.1. Okay, 50 over 1,000 times by 0.1 is 5 times 10 to the minus 3. Okay, put plus in the chat if you're still with me. Okay. Step number 4. So I've worked out this number of moles, okay? So anytime I've got a question like this, I'm going to use moles, okay? It's easier than working in concentrations. Thank you, everyone who has replied. So then I'm going to work out the number of moles of H+. So the amount of H+ ions, right? Thank you, thank you. So what do I do to work out the amount of H+ ions? I've worked out the amount of H2SO4. What do I need to do? 5 times 10 to the minus 3 multiplied by what? Look at the molar ratios. It's 1 to 2. So I'm going to multiply it by 2. Absolutely, to get me 0.01 moles of H+. Excellent. Where do we go next? Well done, Johnny. Well done, everyone else, if you were thinking that as well. Where do we go next? Next, I'm going to have a look at the amount of NaOH, which is equal to the amount of OH minus. Okay, I'm just going to do that in one step here. So I've got 25 centimeters cubed of that. Multiply that by 0.15. What does that give me? 25 over 1,000 times 0.15. So that gives me 3.75 times 10 to the minus 3 mole of OH minus ions. Okay, now this is where we need to use that equation right at the beginning, okay? I'll tell you why. So H plus OH minus goes to H2O. Well, do we know values for these? Yes, for us. I think you've got it. So, however, I think just double check your value for one of the takeaway numbers. So, we know the H plus moles. We worked it out here. It's 0.01. So I'm just going to put it underneath there. Do I know the number of moles of hydroxide? Yay or nay? Yeah, I just worked out. I hope it's correct. It's 3.75 times 10 to the minus 3. Okay, what do you notice about these two values? Is this a similar method to buffer solutions? In some ways, yeah. In some ways, no. But yeah, you get buffer questions like this where you've got one in excess and one limiting. This is effectively a limiting reactants question now, right? Which one of these is the limiting reactant? Which one of these numbers is smaller? It's the OH minus ions, right? That's the limiting reactant. If that's the limiting reactant, by definition, that's going to be the reactant in excess. Super, yeah, absolutely, right? And we've already made it a one-to-one equation here, so we don't need to worry about it being diprotic or dibasic or whatever anymore. It's a simplified solution. So that means, at the end of this reaction, the limiting reactant all gets used up. So we're not going to have any of it left. That's going to go down by 3.75 times 10 to the minus 3 because it's 1-to-1. So let's work out. Yeah, so subtract from acid moles. Absolutely. So 0.01. Take that number away and you should be left with 6.25 times 10 to the minus 3 mole of H plus ions. Was I think you missed a 0 after your decimal point. For the 0.1, it's actually 0.01. And if you take that number away from it, you should get this value, okay? So I think it's a minor thing. Okay, where do we go next? So we've got the number of moles of H plus ions, but I want the pH. And pH is, have a look. Don't you then divide by the total volume? Yeah. So pH is defined as the negative log of the hydrogen ion concentration. Well, I need to convert that moles into a concentration. Well, look, what did I do? I took 50 centimeters cubed of one thing and 25 centimeters cubed of another thing. So, what is the concentration going to be? Well, it's going to be the number of moles divided by the total volume. And the total volume was 75 over 1,000, right? So what does that give us? So 6.25 times 10 to the minus 3 divided by 75 over 1,000. Yeah, we're diluting it up. And we take the negative log of that value. We should get, in fact, what do we get? 1.08 is what I get. So the pH is equal to 1.08. So we've got a shed load of hydrogen ions still floating around after that neutralization reaction. In fact, it wasn't even fully neutralized, right? So yeah, 1.08, well done. Excellent work. Okay, Fawaz got that, Johnny got that. Anyone else get 1.08? If so, well done. That's at least a 4 to 5 mark question, okay? And sometimes they bank on people not going through these types of questions, okay? Sammy, excellent. So make sure you're going through these calculations. We could stop there, or we could do one more. Who's voting for one more? I'm voting for one more. One more? Yay, nay? One more. One more. Excellent. Look at that. Fantastic. I love it. Right. Let's do a hard one to finish on. Because if you train hard, you'll fight easy. And what that means is, I think it's a motto of the SAS, so I've just made it up that it is. But if we do hard questions like this, when it comes to the exam, it's going to be so easy for you guys because you're prepared. Okay. You got to calculate the pH of the solution formed when you add blah, okay, of nitric acid to 50 centimeters cubed of the barium hydroxide. Right. Let's do this, okay? I'm not going to go to math straight away. I'm going to go through my dissociations. Okay, my nitric acid is monoprotic, so that's H plus and NO3 minus. My barium hydroxide is dibasic, and that's going to give out Ba2 plus 2 lots of the hydroxide ion, okay? Where do we go? Let's work out, first of all then, the number of moles. So this time I'm just changing the sort of nomenclature or language that I use. So N is the symbol for the number of moles. So just to make it easier, I can work out the number of moles of H plus. Okay. So number of moles of H plus. Let's start there. I know the volume and the concentration. So that's going to be 50 over 1,000 times 0.25. How can I do that in one hit? Because the number of moles of H plus is equal to the number of moles of nitric acid because it's a monoprotic acid, okay? So that's why I can do it in one hit. 50 over 1,000 multiplied by 0.25 gives me 0.0125 mole. Okay. Chat if you've got that. Sorry, plus in the chat if you've got that. Right. Where do we go next? So now I need to work out the number of moles of BaOH2. Okay. So what am I going to do? I've got 50 centimeters cubed of that. Multiply that by 0.1 to get me the barium hydroxide concentration. Okay, cool. So 0.1 gets me 5 times 10 to the minus 3. So step number 5. Well done, everyone. Is the number of moles. Sorry, I can't type anymore. You should be saying, what on earth is that? So, number of moles of OH minus ions. Have a look. We've got that number of moles, 5 times 10 to the minus 3. To work out the number of moles of hydroxide ions, you need to multiply it by 2, Johnny. Absolutely. So, 5 times 10 to the minus 3 multiplied by 2. Does that give me 0.01 mole? Is my basic maths correct? Yes, it is. Phew. Okay. Now what do we do? Well, in a neutralization reaction, all that is going on is that the H plus is reacting with OH minus to make H2O. So this now becomes a limiting reactants problem. Well, I know the number of moles of hydroxide ions is 0.0125. That's why I put that number directly underneath H plus, okay? I know the number of moles of hydroxide ions, it's 0.01. Okay. Which one's in excess? Which one's limiting? H plus is excess. OH minus is limiting. Good. So at the end of the reaction, that's going to be nothing. None of that's going to be left over because the limiting reactant all gets used up. That's going to go down by 0.01. So what's going to be the new value? 0.0125 take away 0.01. 0.0125 take away 0.01. 2.5 times 10 to the minus 3. Yep, Johnny, absolutely. Sammy, excellent. So 2.5 times 10 to the minus 3. Okay, so we've got the number of moles of hydrogen ions left over. So let's work out the concentration of hydrogen ions. So the concentration is going to be 2.5 times 10 to the minus 3 divided by the total volume. And look, the total volume is 50 plus 50, okay? So 50 plus 50 makes 100. Divide it by 1,000 to give you the hydrogen ion concentration. So some of you are faster than me. So 0.025. Yeah, good stuff, people. And then finally, to work out the pH, we do the negative log of that value. So the pH is equal to, I'm getting the negative log of that value, 1.60. Get in. Johnny, superb. Fawaz, superb. Shrey, pH is 1.60. Well done. Way quicker than me. Well done. Put a plus in the chat if you got that. Okay. Really good stuff, people. Okay, can you also put a plus in the chat if you learned something that you didn't know before? And put 2, put 3. If you actually took something away from that and learned something, found it enjoyable. It's okay to find chemistry enjoyable, okay? There's no shame in that. Learning is fun. Get in. Super. All right. Really appreciate if you guys would just tune in for the next part of this session, okay? So that's that part of the lesson over. Next lesson is going to be weak acids. So we're going to go through weak acids. Once we've done weak acids, I think it's relatively straightforward. We're going to look at buffer solutions, which is quite tricky. People historically find it tricky, okay? So you're all here, that you've taken an hour out of your Tuesday in the run up to Christmas to be here to learn about acids and bases, and that's because you want to secure the top grade in your exam. So well done, okay? Yeah, this is going to be on YouTube, so you can rewatch it, okay? And the point of this is, in addition to giving away chemistry lessons, I can help you get an A or an A star in your A-level chemistry exam, okay? And this is meant to be stress-free, and we're part of a community. And you're also going to be spending less than 5 hours a week on extra classes. And that's, if you can do that now, tune in, have a listen to the information I'm going to give over to you about the course that's starting in January, okay? Now, what's included in this course? Well, you get 2 live classes per week that take place on YouTube, just like we've done so far. So I'm giving you a taste of what the course in January is actually going to be like. You also get workbooks, okay? So the workbooks you will do with me, so you print them out beforehand and you write like we've just done in today's lesson as well, okay? You also get exam style homeworks that are made by me, and you get instant feedback once you've input your answers. But in addition to that, you also get video solutions. So it's me sitting there going through in detail where to get the marks and how to approach the questions to get full marks, okay? How much is the course? Stay with us. I'm going to talk about pricing in just a second, okay? Now, what else is including? Well, you get 24/7 mentor support. So that means you get one of the best experiences, because we've all been there like, oh gosh, how do you answer this question? And you can just contact your mentor and they'll say, oh, this is how you do it. And you think, oh yeah, great, thanks. That's an amazing service, okay? I wish I knew about this before. There's also a 14-day guarantee. So 14-day money-back guarantee, which would pretty much eliminates risk, okay? And you've got access to a community of more than 40,000 students. Why wouldn't you join? So just like I was saying, to protect you from any risk, we provide a full 14-day refund guarantee. And like slapped all over this slide, there's no risk, okay? Absolutely no risk. And let's talk figures. So what are some key figures? There's a question in the chat, how much of the A-level would be covered? So it's predominantly year 13, but not only. So for some topics, I'll be recapping aspects of year 12. For energetics, I'll be going through year 12. For organic, I'll be going through some elements of year 12 because you just can't get rid of them. And also for stuff like KC, KP, and kinetics. So there'll all be a little recap of year 12 as well, time permitted. Now, we've currently got 1,300 plus students studying with us, and 90% of those students will recommend my Headspace. It's a phenomenal figure, okay? And 82% of students got a desired or higher than planned grade, which is also fantastic. Another question in the chat from Fawaz, do you also cover organic chem? Yeah, absolutely. So we're covering year 13 organic chem, but there'll be elements of year 12 organic chemistry as well, stuff like synthesis where we need year 12 reactions, okay? So it's most year 13, but there will be aspects of year 12 as well. Now, if that's not enough, go on Trustpilot. Trustpilot is a place where people leave reviews, and we have an average rating of 4.9 out of 5 on Trustpilot. Absolutely astonishing figure, so it's worth it, okay? Would it help for GCSE Chem? One of the mods will reach out to you, but we are running a GCSE course as well in January as well. And just have a look at some of the hundreds of 5-star reviews that people have left, okay? So this is mostly for the maths course. They absolutely loved the teaching. They love the teacher. They want to be there. They look forward to being there. Sammy, do you go over AS level Chem separately? I'm afraid not. It's just going to be a year 13 course, but check social media. We'll be doing lots of AS chemistry questions on there as well, okay? Now, you can read these in your spare time, but it's a fantastic, look what parents are saying. It's the best way to boost grades. A great course, fun while learning. And some of you were saying that during this lesson. So yeah, join in, be part of the community. I've already asked you this, but why not? More is more. Put a plus in the chat if you've liked the free courses so far. Okay, and I guess now to the money aspect. Thanks, Johnny. Excellent. So the price of the course is £700. And we've already gone through all of the different things that are included, okay? So thanks, Johnny. Thanks, Lakshmi. Thanks, Sammy, for us. How long is the course? Up until May A-level? Yeah, absolutely. Up until May A-level exams. And we'll be doing lots of content just before the exams to make sure that you are exam ready, okay? So just to reiterate, you get live lessons twice a week, and those are 2 hours per lesson. Plus, you got the recording, so if you miss a lesson, don't worry, it's all there. You get exam-style homeworks, mostly multiple choice that you put in. In addition to that, you get detailed video solutions of what the question was actually asking, so me sitting there answering them, okay? You get professionally designed revision materials, you get 24/7 mental support, and you get a community of like-minded learners, okay? And you also now have the opportunity to get a whopping 44% off this course as well, okay? And what does that mean? Well, that means a new price is only going to be £393. Now, if you break it down hourly, that's £4.90 per hour, which is 10 times cheaper than lessons with private tutors. Some tutors are charging sort of minimum 20 quid, but going up to 50, 70, some even charging £100 an hour. And sometimes you don't know what you're getting, okay? But you've got some confidence in what you're getting because I've been a teacher for 8 years, done this for over 8 years, so you know exactly what you're getting, okay? So you're getting confidence is what you're getting. And we can split the price into 2 equal installments for you as well. And that means this discount will be valid until midnight on Friday, okay? So what I'd like you guys to do if you like the course and you like the sound of that, so for Waz's question, when's the start date and when's the end date? So the start date is going to be in January, and that's going to run up all the way till the exams approach. But one of the moderators can give you a little bit of information in minutiae detail of what that's going to look like. So can message our team on WhatsApp. Sure, one of the mods will put the details of that up. Put the keyword water so my team knows exactly who you are and if you're interested, okay? And let's just quickly, yeah, Sammy has done it for me. It sounds like a bargain. It absolutely is a bargain. So some FAQs. Johnny guest, I'll message now. Super. What if you miss a lesson? No problem. All of this stuff is going to be on our online learning platform. It's all there, okay? Will you get enough attention? Well, I hope in this session you've received enough attention. I'm always trying to be interactive with the chat. If you feel like you're not, you can also reach out to your mentor. You can have a personal mentor assigned. You can always talk to them and they'll reach out to you straight away and give you advice on how to answer questions. How would you ask for help? Well, loads of you have asked for help already, so you've done that, but you've got access to your personal mentor for any questions you may have, and you're also joining one of the UK's biggest chemistry communities, so you're also getting support from peers, and don't underestimate that, okay? Peer-on-peer learning is a fantastic tool to actually check for your understanding, so be part of that. Will the lessons be useful for me? I suppose that's value driven, but you've got to have a little think and actually ask yourself, is this valuable for me on this Tuesday night? And a lot of you have said it is. So yeah, hopefully it's valuable for you. And 82% of our students have achieved or surpassed their goal. So there you go, right? With our 14-day money back guarantee, it also means you can try it with confidence, knowing that you can get a full refund if you're not content. I mean, it's a bargain and one additional extra, okay? So there's no risk really associated with this as well. Remember, message me on WhatsApp, message our team on WhatsApp, put the code word water so you know that my team, they know that you're interested, okay? It's been a real pleasure doing that lesson. It was good fun. Looking forward to the next lesson. Just keep track of social media of when the next lesson is going to be, or just ask somebody in our team, and I will see you soon. So thank you very much for turning up on a grim Tuesday night in London, but I hope you made it a little bit more fun. Okay. Have a good night, everyone. Been an absolute pleasure. Take care. I normally say ta-ta on my social media stuff, so I'll start saying that as well. Ta-ta for now. See you later. Have a good one, guys.